Sweet. All right. Welcome, everyone. I'm Erik Darling. I am going to, I don't know, I call this session the SQL Server Performance Tasting Menu because I have a bunch of sort of small demos that don't necessarily all go together and tell a story, but they're all pretty fun to do, and they kind of switch things up a little bit so that everyone, like I want a little something to appeal to everyone. I don't want to get started and like do like this storytelling demo and have people like zone out and get bored and be like, this is not what I signed up. I'm not into this. So it's like to tell a bunch of little stories, kind of like I don't know, what do they call that? Novellas or something? I don't know. I don't read books. I couldn't tell you that. I didn't finish high school. It's a big problem for me. Anyway, the first thing that we're going to talk about is however you pronounce that in French. I've been to a restaurant where they talked about these things before, and apparently they're delicious. Everywhere you go, they're always different, but they're always delicious. Anyway, we're going to look at trivial plans a little bit because trivial plans do some kind of funny things. And Eugene, you are not muted. And
apparently not. I apologize.
No worries. Just want to make sure that you're okay over there. It sounded like
no, I'm glad you didn't hear me calling my dog Papadino or anything. All right,
yeah,
proceed.
well, all right, let's go. So what we have here with a trivial plan is when SQL Server sees your query and it thinks about the execution plan that it's going to come up with, and it says, we got this. There's not a whole lot of choices for it to make. The way you figure out if you have a trivial plan is you look at your execution plan, and you say, yeah, that's boring. No, I'm kidding. That's not what you do. What you do is you right-click and you hit Properties. And over in this window, you're going to see an optimization level. I'm going to hope that the VM zoom it works as well as it always does, but who knows? It's been a funny day, and all sorts of funny things might happen going forward. So the optimization level for this plan is trivial, meaning that SQL Server didn't have any real big decisions to make when it ran this query. You can do some pretty funny things. And you can introduce some operators into a query plan and still have a trivial plan. So if I run this where I get a row number and I partition by stuff and I order by stuff and I look at the execution plan, it is still going to be a trivial plan. And the reason it's still trivial is because SQL Server still didn't have a cost-based decision to make. It has to use these operators no matter what. There's no decision for SQL Server to say, but what's the best way to do this? SQL Server doesn't have that choice here. Where you start to have that choice, or like where these choices start to come in, is when you start giving SQL Server some things to think about. Now, I'm going to show you 3 different queries. The first one is a distinct top 1000 on a column that's already unique. It's the primary key of the users table. So SQL Server can look at that column and say, every value in here is unique. I don't have to think about any special way to make this distinct. Then down here, there are 2 queries where I'm using the reputation column, but I'm getting a different number of rows out of the table. So if I run these, we're going to see 3 different query plans. I mean, at least that's what happened when I ran the demo before. Who knows what's going to happen now live and in person? And we're going to look at the properties for all of them real quick. And this plan will be trivial, right? The select with the distinct column, trivial. And then these 2 plans down here are going to have full optimization. If we zoom in a little bit over here, optimization level is full. And if we look at this one, optimization level is also full. Yeehaw! SQL Server finally had a choice to make. And if you look at the execution plans there, if you look at the slight difference in them, it's in how SQL Server decided to distinctify, which is a real word I'm told, that data. For the select top 1000 rows, it did something called the hash match flow distinct. I'm not going to get into what these things do behind the scenes or the technical details, but you can see that they're different operators. SQL Server chose to do things differently based on how many rows were going to come into those plans. And because of that, SQL Server's optimizer said, well, we better fully optimize these queries. We better get to that. Now, it looks like I scrolled over a little bit too far in that window, and that just made me look like a completely unprofessional. I'm a bobbling boob is what I am. So SQL had a choice to make, and we finally saw a fully optimized execution plan. Some other kind of obvious things it will get a fully optimized plan as well. If you need to join tables together, or if you need to order by a column that doesn't have a supporting index, these plans will be fully optimized. Another good way to tell is if you have a parallel plan, you have a fully optimized plan. SQL Server won't explore parallel plans in a trivially optimized execution plan. Another way to get a plan that gets full optimization is to do something like a subquery, right? So if I run this subquery query, we're going to see an execution plan that looks a lot like that join query. That's because subqueries are often optimized out as joins. But we can do an even simpler subquery and still get full optimization. You see, these two queries here, the only difference between them is instead of selecting ID up here, I just have select ID as ID. That's the only real difference. And when we look at the execution plans, well, they're going to look pretty similar. You have that compute scalar in the bottom one, but that costs 0%. So how could that possibly need to get fully optimized? Who knows? Paul White knows. I don't know these things. But if we go and we look at the the operator properties here, try saying that 10 times fast. I'm going to be doing that all day. Operator properties. This top one has a trivial optimization level, and this bottom one has a full optimization level. Just by sticking that ID column inside a select, SQL Server went, holy cow, like break out the good linens. We got special coming. It was like all excited about this. It was like, you know, SQL Server got all excited to optimize this query. Who knows why? Who knows why? Another way is to do something kind of funny in the where clause. Now, that where clause where 1 equals select 1 doesn't affect the logic of the query. It doesn't return a different count. It doesn't make SQL do any extra work. It's comparing the number 1 to a selected number 1. But when we run these two queries, we will look at the execution plans. And even though they're the same, SQL Server didn't make a different choice here. This top one is trivial. And this bottom one is fully optimized. Again, trumpet sounds, all sorts of good things happening there, right? So the reason we care about trivial plans, and the reason why trivial plans can sometimes be a little tricky to work with from like a query tuning standpoint, or like figuring out like what's wrong with this query, why aren't you better, why aren't you faster, is that you miss out on some optimizations when SQL Server stops early. When SQL Server says, this plan is trivial, I'm not thinking about it, I just don't care, just get it out of my face. Like I have big like reporting queries to deal with. I can't deal with this nonsense. You start to miss out on some of like the cooler optimization stuff. Like for example, because everyone seems to love these things, if I run these two queries back to back right here, we'll notice that this top query has absolutely nothing going on for it. It is a trivial plan, I promise. And this bottom query, well, it has a missing index request on it. The SQL Server, because this execution plan crossed the boundary, and the SQL Server said, you need to be fully optimized. All of a sudden, SQL thought about it a little bit longer and said, well, maybe an index would help here. Maybe if we had a good way to find reputations, that this query could do better. I don't know. Just throwing it out there. So that's one thing that you miss. Another thing that you miss is potentially the use of valuable check constraints. Now, I know everyone out there has all these fully trusted check constraints. Your database integrity is pure. It's just, you know, it's unreproached. You are the absolute best. You have the most pure data on the planet. It makes your face numb when you look at it. We create this constraint on the users table, right? Look at this. Here it goes. Now SQL Server knows that every value in that users table is between 1 and 2 million. There's no doubt about that. We can even validate that with a really, really straightforward column in this view where is not trusted is 0. So it is not trusted. Got it? We're cool on that. The problem is, when we run this pretty simple query over here, we hit F5, right? Look at the execution plan. We scanned the clustered index, even though we went looking for reputation equals 0. I'm going to show you why that's bad. Look at these two execution plans and note this subtle difference. This plan down here that got full optimization on account that I stuck that 1 equals select 1 on the end, well, that gets a constant scan, and this thing runs for 0 milliseconds across the board. This top one, well, SQL Server didn't quite get the memo, and we scanned the clustered index. And if we look in the Messages tab, we'll see that indeed SQL Server scanned for that first query, read the entire clustered index to find nothing. For the bottom query, it didn't do anything. If I run that bottom query by itself, stats time and IO output tells me absolutely nothing. So you do miss out on some things when your plans are trivial. You might find SQL Server maybe not giving you the kind of feedback or using the kind of constraints that you create in order to make things better for your end users. And so you just feel better on the internet.
So you said to rudely interrupt you. Two things. One, that's
boy.
horrifying.
Yeah.
To do a scan to pull back absolutely nothing.
Yeah.
And then LondonDB had a question. Are trivial plans cached or are they compiled each time they're run?
No, they're cached.
Okay.
Yeah, they'll go hang out. SQL Server will happily reuse a trivial plan over and over again. SQL Server loves reusing plans. It's like this, I don't have to do any work. I can be lazy. I can go do other stuff. I can play Xbox and eat donuts. SQL Server loves using cached plans. All right. Any other questions?
No, I don't think so.
No? All right.
You're good.
It's a world record for questions on trivial plans. Anyway, let's talk about common table expressions. Let's first talk about why we have them, because they're a strange beast. They're kind of a weird thing in SQL Server. So we have them because derived tables have limitations. Now, if I select star from, I highlighted a little too aggressive on the highlighting there. If I select ID from this table, I can get that data back. And if I select star from that table aliased as X, I can still get data back. But if I want to join X to itself and say I want to reuse X, all of a sudden SQL Server says, no can do, pal. I do not know what X is anymore. I have lost track of what X could be. I'm sorry. You're going to have to rephrase your question. CTEs don't have that limitation, right? So if I run that same query as a CTE and I join that CTE to itself, I can do that. SQL Server will happily say, oh yeah, that X. Yeah, I remember her. She's great. That's why she dumped us. She's just too good for us. But SQL Server now knows what X is. That can backfire though, because the more times you decide to have SQL Server remember who that X is, and you look at the execution plan of your X, well, some funny things start to happen. Every time you join a CTE, right? Every time you like reuse a CTE in a join, you start re-executing the contents of that CTE over and over again. Not exactly the way people think about them all the time. A lot of times when I talk to people, they have these funny misconceptions about common table expressions where they're like, well, they get cached. They're like temp tables. What should I use, a CTE or a table variable? Neither. Run screaming. But that's like a real drawback. So like the one thing that really differentiates them from derived tables is also kind of like a big Achilles heel for them. Because what I see a lot of people do is write these big crazy queries and they're like, well, I put you in a CTE. Now I can have a SQL Server remember what I did. And they get these big execution plans. And then they go and reuse what the contents of those CTEs, like, well, I needed to get a row number. So I can just reuse that row number. I don't have to think about that row number over and over again. I can join on row numbers now. This is great. But your query plans tend to suffer a bit as you reuse CTEs. Now, it doesn't execute this exact branch over and over again, but if we, I'll just redo that so I don't have to like mess with zooming. But if we kind of zoom in on this bottom part, you can see comments, 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 posts, 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 and that 3-table join will continue up through votes and badges and users, and it's all just kind of a horrible nightmare. So the real message there is don't reuse CTE. So when you don't join CTEs to each other, because bad things will happen to your life and your future and loved ones, and you may end up unemployed. Who knows? But now, CTEs can also help with things to a limited degree, but this is also where I need people to understand that they are different from temp tables. So a long time ago, I did this presentation on performance tuning select star queries. And I have this demo that I love using because it demonstrates both things in a really nice way. So I have these indexes up here. For users, it's on creation date, reputation ID. For the post table, it's on own user ID, blah, blah, blah. You can read, you're, at least semi-talented human beings. You can click on a Zoom link and get here. So I assume you can read this thing. But you can see that I'm selecting everything from the users table, which doesn't help, this index doesn't help. But my join and where clause is really, really could really be helped by this index. Creation date, reputation ID, I'm filtering on all those things. So one might expect SQL Server to be able to use that narrow index to help the where clause, go get the columns from the base table, then do other stuff like join off to the post table and blah, blah, whatever. Unfortunately, SQL Server doesn't make that choice. SQL Server says, nah, I don't know about that. I don't really think that's a good idea. See, SQL Server thinks that we're going to get 26,000 rows out of there, but we only get 4,600 rows out of there. Well, I guess we can call that 4,700. That's close enough, right? You can round up a little. I'm not good at math, so I just call that 4,700. But SQL Server makes a different choice because it makes a bad guess. The SQL Server doesn't use our index. I don't like that. I didn't stay up all weekend creating that index so SQL Server wouldn't use it. So now I'm going to challenge SQL Server a little bit. I'm going to say, SQL Server, I want you to use my index. I spent time away from my family. I nearly starved to death on a raft. But when I run that query and I force SQL Server to use that index, I get a much faster query. Right? Remember this one up here? Right? This took about 1.5 seconds to run, which is not really all that fast for me. It's 3,000 rows in 1.5 seconds, 1.743 seconds. That is not a good row to seconds ratio. It's a terrible row to seconds ratio. When I force the index, it's nothing. It's milliseconds, right? 1.49 milliseconds. I like that a whole lot better. So the way that I got SQL Server to use my index for this was to stick the beginning of the query in a common table expression. Right, and I'm only going to select I'm going to only select a narrow list of columns in here. Right, so when we write a query and we think about the columns that we're using in the query, there are really two kinds of columns. There's the informational columns, which are things that you're going to show to the user. That's basically what's made up in this select star down here. And then there's the relational columns, and the relational columns are the things that we're doing: joins and group by and order by and filtering on with our where clause. So we can take a query and we can break it down with those constituent parts, and we can kind of say, we can separate when we do our relational activities from when we do our informational when we go and get our informational data. And I found that when I stuck the narrow part of the query in a common table expression, and then outside of that common table expression, I went and joined stuff later, well, I got a really fast query, right? Down to 1.114 milliseconds. Right, 114 milliseconds, and I was really happy with this. I was like, this is great. I can go use this trick all over the place. But, and you can, if you know, if SQL Server just makes a bad guess and you really want it to point it to, get it to use some indexes, you can totally do this. But it doesn't work for a very, very long time. So if we go back another year, let's say up here, I was filtering back to 2013. This is the Stack Overflow 2013 database, so it ends in I think Christmas. It's almost like a really bad prophecy movie, because the world ends for the Stack Overflow database on Christmas, so 2013. This query here, if I go back to 2012. And I look at what happens. Well, I'm not going to run the query because it takes 5-6 seconds to run, but it's a totally different query plan than the one we got before. It's not sticking to the plan shape that I want. It's not a good query plan for more data. So the CTE worked well initially, and the optimizer was free, but the optimizer was ultimately free to work around it when it saw different numbers of rows were going to start coming out of things. So that's the kind of one downside. Well, that's another downside of a common table expression. So the first one is, every time you need to reuse that common table expression, via join, you have to re-execute the syntax inside. And the other one is that it's not a fence, right? It's not something that SQL Server looks at and says, you can't go past here. We're going to make this is special. This is sacred query ground. You can't mess with it. With a temp table, you can get that guaranteed separation. So rather than put that data, or take the data from that CTE and try to get SQL Server to treat it like it's extra special, I'm just going to take that query and use it to put data in a temp table. Now, ladies and gentlemen, I want you to see here why SQL Server is worth up to $7,000 per core of Enterprise Edition. Boy, that's fast. Look how fast SQL Server got data into that temp table. That's fantastic. Can you believe no one would pay $7,000 a core for that kind of action? Even better, now when I select data out of that temp table and I join back to the users table, that's crazy fast too. If I do the whole thing at once, right? If I go grab this, drop table, create table, insert data, it's still fast. You can't beat that. But things sort of, again, they start to fall apart when more data comes into play. No, it's not this part. This part is still fast. We have to put more rows in the table, but that part's still quick. What's not so quick now is when I select data out of the temp table, well, I have to show people a lot more rows now. I have to show people 366,416 rows. And that's not a good time. I'm going to go out on a crazy limb here, and I'm going to say, if you ever do a search via your favorite search engine, whether it's DuckDuckGo, Google, Bing, Dogpile, whatever it is, you're not ever getting 366,000 results in. You're like the first three, like 1 to 3, maybe 5 pages if you're into like some weird deep web stuff. You're not going to really go to, like, you're not going to go too far in. And when you do, what happens when you get to the end of your search engine? You click next, right? So what was fast here was getting all the data we cared about, sticking it into a temp table, and what was fast was showing kind of like a limited number of rows from it. So if I just select the top 3,006 rows, which is exactly how many rows the first query put in there, well, that's fast. So what might be a good way to do that with SQL Server? Well, let's talk a little bit about how SQL Server can be used with paging. Now, I kind of spoiled the whole thing there. Any questions on that? How are we doing?
I think we're good. I don't think I see any questions. Yeah.
People are just
Wonderful.
talking about how much they like it. Like,
Oh,
not really
great.
a question, but yeah.
Yeah, that's okay. You can tell me that lie all day long.
Blythe Morrow says in all caps, who wouldn't want to pay $7,000 per core for this?
I know. It's fantastic, right?
And she said sup.
Oh, hi.
She said both. Yeah.
Yeah. All right. Well, thanks. Now my game's all thrown off. Now I'm a little nervous. Now I know that Blythe's here. I'm all messed up. So there are a bunch of ways that you can use SQL Server. There are a bunch of tricky things you can do with SQL Server to page through a data set. I'm going to show you my 3 kind of favorite. You can just like do a regular thing with row number, and you can use some variables for page number and page size. And this will be fast, right? Getting that first page of 100 rows is fast. And you can also use this technique, which I learned from Paul White, which is stacked temp tables. Now, this doesn't have the same problem as joining temp tables together. So if I have one CTE and then I like select from that CTE, it doesn't have the whole like re-expansion problem that joining them together does. And if I run this will still be fast too. Oh, probably should get those variables up in there, huh? I don't want to see any red text that I didn't plan on seeing. So this is also fast. And I can also, if you're on a newer version of SQL Server, I say like newer version, like it's it came out in 2012, or it's 7 years old now. So a newer version, I guess to most people, since anything beyond that's like unsupported now, unless you go pay Azure bucks. This is fast too, except I didn't select those variables, and I can't believe my helpers didn't yell at me. What am I paying you people for? But this is also quick. So there are 3 different ways to page through a data set that are all relatively fast. These all will start to fall apart when you get deep into a data set. So I'm going to ask for page 1 million. My page size is going to stay the same, but when we get deep into a data set, it takes longer and longer to kind of get to the rows we care about. Right? It takes a long time to kind of get to where, even though we don't have that many rows, SQL Server still, like the obedient dog that it is, will try to find those rows for us because you asked for them. You like pretended to throw that stick and then you're holding it behind your back and you say, go get it, SQL Server. And you're just holding the stick and SQL Server is going to run and it's going to go look around confused for those rows and they're not going to be there. Then SQL Server is never going to trust you again, ever. But you can see this query took about almost 6 seconds to run. The arrow going to this top, we had to go through a lot of rows to find none here. So SQL Server did a lot of work for nothing. The other place this can fall apart, and God help, but if we try to run any of these queries, now if we have an order by on a different column, before we were just using the ID column, now we're going to order by last activity date. The reason I'm using last activity date versus a different date column in the post table, there's another column in the post table called create date. The funny thing about create date and ID is that they're kind of well paired together. They're both like ascending keys. So ID is just like an identity or identity-ish column. So that's going to grow every time. And create date is also going to follow the same pattern. So if we wanted create date, we could totally just use ID to order because you're going to get the same thing. Last activity date's different. Last activity date's all over the place. Someone could ask a question on Monday, edit it on Friday. Someone else could come along and edit it a year from when it got created. So last activity date's all over the place. Now, the thing is, if I don't have an index on last activity date to support that sorting, all of these queries that used to be very, very fast now become a bit slower. They do not do as well under pressure having to sort data when we don't have a good index to help. All of these things take about 5.5, 6 seconds. Not a good time. If we go and we create an index on last activity date, well, I mean, creating the index is pretty quick usually. I mean, I said it was quick now while I'm live and talking to people, so it's going to go slowly. So there's always that. But anyway, oh, what was that? 6 seconds? Not bad. All right, so now let's go and run these again with our index. And now with our index, these are all fast again. So server-side paging can work well. You can totally learn how to live well with server-side paging. It's always a great idea if you can limit the amount of data you're shoveling off the app servers, because app servers generally aren't the most powerful thing in the world. And when they get like 3 million rows shoveled at them, just like, it's a bad day for them. Because I know what happens when they get those rows and they do the for each loops over every single thing. And they do all sorts of fancy, display level stuff. Server-side paging can also work well if you have pretty predictable user query patterns. So if you don't have to, if you don't have to worry about, oh, what are users going to sort by today? What are users going to select today? What are users going to where clause today? If you have a pretty predictable workload, you can also get along pretty well with server-side paging. Where it gets really tough is when you let users choose which columns they want, which tables they want them from, what their where clause is, what they're ordering by. The more customization you give users on the front end, the harder it is to index for all of those potential queries. It's not a good idea to try to keep up with it. My big experience was with this when I was a DBA for an e-discovery shop, and we had lawyers come in and they were querying databases with different stuff all day long. The problem is they would search for one thing one week and another thing the next week, and keeping up with the indexes they needed week to week was a real chore, especially because these databases are like terabytes in size. If users need that much customization, excuse me, it's usually a better idea to take that work out of SQL Server. Something like Elasticsearch, which was made for this sort of thing, is usually a much better match. Any questions on that part?
No, I think we're good.
Sweet. Cool. So we talked about sorting data and how sorting data can make SQL Server do work, and how indexes can help SQL Server do that sorting work. But I don't want you to think that just because we need to sort data, that column has to be very first in the index. SQL Server actually has some really cool ways to use indexes to sort data that don't always involve having them to be the first column in the index. So why do we care about sorts? Well, one, we just saw how much they could slow queries down. SQL Server waiting for all those rows to show up and then sorting them, asking for a bunch of precious memory to sort all those rows. When they don't get enough memory, they might spill the disk. Right? They make code sensitive to parameter sniffing. If, say in the first run, you sort a little bit of data, and on the next run, you sort a lot of data. Well, SQL Server might not choose the best sort for the big data when it only has to sort little data. And they're internally blocking. Like, they don't go out and block other queries, but they do kind of block themselves because they're waiting for all the rows to show up at the sort operator so they can start sorting. So if I have this index, lovingly called Spooky Mulder, because I was probably watching the X-Files when I wrote this demo, which is always entirely possible. It is on reputation descending, upvotes, and it includes display name for reasons I'll get into later. But let's look at these two queries, and let's ask ourselves, do we need to sort any data when we run these queries? We're selecting some columns from the users table where reputation equals, I think that's 100,000 on the first one and 0 on the second one. We're going to order by upvotes descending. All right, so we have to order by upvotes. Upvotes isn't stored descending in the index, and it's second in the index. But when I run these, SQL Server does not have to break out its little baby hands and start sorting data. We just have a simple index seek in both of these. There's no sort operation happening. What about these? Now, In the first one, we're looking for data that's over 100,000. And in the second one, we're looking for data that's less than or equal to 0. Now, we know there's no zeros in there. There are probably 100,000s in there, but when we run these queries, well, we need to sort data now. Now SQL Server is not so sure about the order that things are going to be happening. And SQL Server says, well, we better make sure that it's right. SQL Server breaks out these sort operators and says, oh yeah, you get in here. Get in here, Ollie. What about these? Now, we just saw these inequalities mess up having to sort data up here. What about down here? Now we're going to order by reputation, ascending. Remember, reputation is descending in the index. What's going to happen? What is SQL Server going to get up to? What will these execution plans look like? No sorting. Amazing, right? So we learned that SQL Server doesn't need the sorting element to be the first column in the index in order for it to sort properly. As long as we have equality predicates up here, or if we're sorting by the first column, we can have whatever kind of predicates we want down here. But as long as we have equality predicates in the first column, we can sort by the second column, or even like if we have equality predicates across the like 6 columns, you can sort it by the 7th column if you wanted. But as long as we have some equality predicates leading up to what we want to sort by, we're in pretty good shape. So let's look at a more complicated sort. And let's look at it with this query plan. Now this is why display name was in the index, because now we're selecting it. We're still filtering on reputation. We're still ordering by reputation. And when I run this query, I'm not going to run it because it takes a long time to run on its own. But we don't have to sort over here. We do have to sort down here, but we're sorting the post table. We also have this big gnarly index spool over here. If you want to learn why index spools are bad, go to this link right here, bit.ly/spool bad. That is case sensitive because I don't know, that's bit.ly why it's case sensitive. So that wasn't my choice. So there we would have to sort data, and it would be pretty painful. Now, where a lot of people get thrown off is by thinking that they do need to have that first sorting element in order for SQL Server to properly order data by that. So since we have scored ascending, we're going to order by scored ascending. And since we have owner user ID and a join, we're going to use owner ID here. And the index is filtered down to post type ID equals 1 here. So this sounds like an okay index. The problem comes when I start running this query. This thing, it starts returning rows quickly, but it just runs and runs and runs forever. This is not a very good index for this query. And looking at the query plan, it's pretty hard to tell why. I mean, if you really look at the query plan, it's not that hard to tell why. But just looking at the query plan, you're like, oh, that's pretty easy. But if you think for every row that comes out of this table, we have to fully scan the post table, that's not so great. We're not even fully scanned. We just have to get the first 10 rows out, but you get what I mean. It's a bad time for SQL Server to just do that in a loop. So a better index would be this one, which leads with owner user ID, then has scored ascending, then has post type ID equals 1, because this query finishes instantly. That one's just done. There's no sorting when we're able to seek on this side of the nested loops join, which makes our lives a lot easier. Now, the reason why this is possible is because, well, we wrote this query with the cross apply, and thankfully SQL Server chose the apply pattern when the query optimizer went and looked at it. And because for each row that comes out of the users table, we're able to look into this index, and we're able to look for each owner user ID, where post type ID equals 1, we have our index basically sorted by this column. So, and this gets an equality predicate. And so then the next column over is scored ascending. And so we have our data sorted by that. So now we don't have to sort data any further. Now, that sounds great. That sounds wonderful for that kind of query. I don't know how many people out there write crazy cross-apply queries, but it's one of my favorite tricks because you can do all sorts of fun things with it. But where things start to get a little trickier is when you write queries that do more, right? And like queries that sometimes look are very intuitive to write, pretty simple, but turn out to be pretty difficult on the optimizer. Now, or just kind of do things you might not expect the optimizer to do. So here I'm creating an index on the votes table, and it's on 4 columns, and you can see pretty much why I created that index based on the query that I'm running. I'm looking for vote type ID in 1-3, so an equality on 1 and equality on 3. So vote type ID is first. I have a row number where I'm partitioning by post ID and ordering by bounty amount descending, so that makes sense here. And then I have an inequality on creation date. So if you remember back to the earlier demo, if I had creation date right after vote type ID in the index, I wouldn't have these things in the order that I wanted when I ran this query. So I'm doing all this work, and I have the row number getting generated. And down here, I'm kind of playing a funny trick to return 0 rows. I was actually kind of surprised that SQL Server like did any work here, because like row number is not going to be 0, but you know, I guess how would it reasonably know that? So I ran this query, and you know, that execution plan just really didn't do what I wanted it to do. Sure, we did a seek into this index, but boy, oh boy, we spent quite a while sorting that data. And I wasn't very happy with that. But it turns out internally in, it isn't so simple as 2 equalities to SQL Server. Sometimes it can end up as OR, sometimes it ends up as a weird range. Sometimes like SQL Server can take this and do all sorts of oddball things with it. So I had to rewrite this query, and I had to rewrite it to run that query twice. So remember, this one ran for about 6.2 seconds, did a whole bunch of work, but now I have 2 copies of this query, one that looks for vote type ID 1, one that looks for vote type ID 3. And when I run these, well, things are a lot faster now. Right, we're down to 2 seconds, or I guess almost 3 seconds. So still about twice as fast, but we do our seeks and we don't have to sort any data. And now we're not at risk of having to spill anything out to disk. So all in all, this is a way to get around having to sort where that in up here kind of sabotaged us. Any questions on this part?
No, I think we're good.
No?
Yeah,
All right,
still
sweet.
doing good.
Let's get on out of here. All right, we're making pretty good progress. I don't know if we're going to get to 12, but we'll get to as many as I can. If I can remember how to find the next one. So this is about complexity, and it was a good example before of how an overly when we sort of reduce the complexity of a query, SQL Server was able to come up with a better execution plan. We're able to eliminate some work SQL Server had to do. Now, the query that I'm going to run now, and I really hate when code gets overly explained in demos, so I'm not going to do that. I'm just going to point out that we have a common table expression that does some stuff here, one that does some stuff here, and then some that joins them together here, and then we do some more work. This is basically a really long query, but this is the kind of query that I walk in and clients expect me to tune every single day. And I'm going to put the results into a temp table if I learn how to click on things. So, oh wow, I went all over the place there. So I'm going to drop the results into a temp table so we don't have to wait for a bunch of rows to return, because that's no fun. And this is going to run for a long time. This is going to run for around about 25 seconds while all of this crazy stuff goes off and happens. Now you can just like look at this code and wonder at the majesty of like, how are we ever going to tune this? What are we going to do? There is just so much going on in here. I don't even know what index to make. What exists? There's CTEs joined together. Like, what on earth is going on with this query? Like, I don't even understand the point of it. There's no comments on it. So it's just like real life. It's code that you would understand that has no comments, and it takes about 30 seconds to run. If we look down here on the bottom, oh boy, 29 seconds. That's no bueno. Can you tune this? Sure. But I don't want to deal with that. Look at this execution plan. Look at this thing. I don't want to figure out why this big thing is slow. This is ridiculous. It's too much. Too much. I don't sleep enough to tune execution plans that big. Whenever I see a query like this, my first instinct is, well, it's good. It's probably bad for a lot of reasons. It's not going to be easy to figure out exactly which reasons by looking at that query plan. It's time to break this thing up into some pieces. So I like to look for logical stopping points in a query. It doesn't have to be CTEs. It could be derived tables. It could be really anything. It could be if someone has a derived join. It could be, I don't know. Now that I'm on the spot, I can't think of anything. But when I thought about this earlier, I had a lot of good reasons. But what I'm going to do is just kind of take the first section of that. Right? I'm going to take these first 2 CTEs, and I'm going to stick those into a temp table. So let's go and stick those in and have fun. Now, the whole point of this part of the query is to make sure that users weren't self-answering their questions. Right? And when I run that, it takes about 4 seconds. That's not bad. I do want to point out that when we look at the estimates, oh, you went away, you sneaky dog. When we look at the estimates, SQL Server estimated about 2,500 rows, but got about 2 million rows. So we can kind of start to figure out why that other query was so slow. If I was really, really invested in tuning this, I might take some time to do more work here to figure out if I can get this faster. But for right now, let's see what other parts of the query look like when we run them. So the next CTE that ran was this one that looked for votes that had bounties. But we're kind of doing something crappy to ourselves. We have an or in that join clause. All right, so we have the join votes on, we're joining no collusion to votes on these two columns, but there's an or in there. And SQL Server is going to freak out about that or. SQL Server is not going to be happy with that or. We are going to get or to death. And this query is going to take 17 seconds to run. Looking at the query plan, you can kind of start to get a feel for why. We do a bunch of work over here, and for some reason we spent nearly 8 seconds sorting data over here, and that's just all sorts of wacky stuff happens. So we're gonna reach into the old trick bag, and we're gonna do exactly what we did with the previous query, and we're gonna run these two separated with a union null. So we're gonna break that join with the or clause up into 2 queries, and now we're going to have a much faster query. So rather than taking, I don't know, what was that, 17, 18, 19 seconds, this takes still a little bit under 2 seconds. So we have a query that runs about 4 seconds and a query that runs about 2 seconds. That's 6 seconds compared to like the 30 seconds that the whole thing ran for. Now, if we take that final part and we join that off to our temp tables, this will finish pretty quick too. That finishes in about 2 seconds. So now we have about 8 total seconds of runtime. If I turn query plans off, right, because there's some overhead to collecting query plans, especially when they're big, gnarly, nasty ones like that, and I run that whole chunk together, remember that the initial query took about 30 seconds, and I run this should finish in around about 5 or 6 seconds. I didn't change any of the logic. I didn't rewrite the query in any meaningful way. I didn't start pulling things out. I didn't change indexes. All I did was break this query into more bite-sized bits for the optimizer to deal with. That's it. That's what gets me a lot of performance gains when I'm out working with people, is just taking the big complicated stuff, breaking it down into smaller chunks, and then from there, like I said before, I could go back into all of these queries and I could probably do some work to get them faster. But if I can really quickly get something that takes 30 seconds to take like 7 seconds, most people are like, cool, we can live with that. 30 seconds sucks, 7 seconds is great. Let's move on to something else. Like that's already kind of enough of a win for them. So big complicated queries can go pretty good with data warehouses, right? Or extremely lucky people, or people who have extremely small databases where the queries don't ever run that long for. Sometimes you can get an obvious index and fix things like that, but more often, really what I find is just taking the big complex stuff out of queries, breaking it up into small chunks. Then you actually can start to figure out where things were going wrong, and you can make really fine-tuned choices as to how you're going to tune things next. Were there any questions on that?
No.
No. Wow, wonderful. People are just too smart for me. I don't know what it is.
Does everything you say just makes perfect sense?
I guess so.
I always get paranoid when there's no questions. It either means I'm doing a great job or a terrible job, right? And I can never tell.
Yeah. Well, I mean, for you, it's always a terrible job, so just don't worry about it.
That's why I didn't get selected for GroupBy. No one wants to hear about business intelligence. It's all just a bunch of, yeah.
Let me teach you query tuning. It'll be fun. You'll get all the good slots. So
yeah, that's true.
you could sleep until 4 p.m. like I did today. I'm kidding. Went to the gym. I did lots of productive things. So I want to talk about how missing index requests can sometimes backfire. Now, this is inspired by something that happened with a client, where once upon a time they had a stored procedure, and somehow someone had passed a weird value into that stored procedure. And when they passed that weird value in, they got this terrible execution plan that broke things. So inside the stored procedure, they declared a variable, and they inside of the stored procedure, they fixed. So if there's no more negative values, if you get another negative value, we're going to fix it we're going to set it to 0, right? Or we're going to multiply it by +1 so it changes. Like we have to do something here. So they had this store procedure and it did that. And this store procedure, well, it had a nice index to work with on owner user ID. It had one of those single column indexes that turned out to be very helpful for some reason. I don't know. Sometimes I talk a lot of crap about single column indexes, but then once in a while I'll see one doing wonderful things in production and I'm like, oh, all right, you can hang around. But when we look at this query, this thing runs fast. All right, that's pretty quick. Runs in 0.76 milliseconds. That's under 100 milliseconds for anyone counting at home. I can run that a whole bunch of times and it'll always be reliably fast using that single column index, doing a key lookup for a few rows and then chugging along. SQL Server, sure, it's asking for an index over here, but let's ignore that for now. Because, really, like if I see a query that's running in 0.86 milliseconds, I'm not like rushing to index for that. I'm like, you're fine. Like we don't need that for anything. That's not gonna get us out of the hole. But let's say that we have another query, and let's say that this query, I don't know, runs at night and it runs a lot and it does a bunch of work, and when it does work, it's pretty slow. And when, like if you go and look at missing index requests, you'll see that this query has a cost of 3,098 query bucks. And if we add this index, it'll solve 99.9986% of our problems with this query that costs 3,098 query bucks. The problem is that missing index DMVs don't tie well together with a query that asks for them. There's like right now, there's no magic like, oh, that's the query that wanted it. We can ignore that. We don't need that index. So let's say that this thing runs a ton. And if we go and look at missing index DMVs, we might see what looks like a really important request. Like let's say this is like hundreds of thousands of uses, really expensive query, like big impact. Wow. This is the query that SQL Server is asking for on this. So let's say that, like, we look at those missing index DMVs and we're like, man, we got to do this. If we don't do this, the service is going to catch on fire. Poor CPU fans, they must be very dizzy. So we'll add this index. And when we add this index, which is not like a very aggressively bad index, it's 3 key columns, includes 1 column. I'm pretty okay with that. That's not like, I'm not sweating an index of that size. And that index really does help this query. It costs almost nothing to run now. It finishes instantly. But the problem is that now our query that runs during the day that people care about and that we need to be fast, well, that used to finish in less than 100 milliseconds reliably, this no longer finishes anywhere near that fast. It drags on and on and on for 13 seconds now. And it's using our really fancy new index from our really fancy missing index DMV. Well, SQL Server made a pretty bad guess here. It estimated 1.8 rows, and only have to read 3.05086 rows, but in reality, we did a whole lot more work than that. It took us a whole lot longer to go and find that data that we were interested in. We had a different index that SQL Server started using. We had a plan regression. And SQL Server made that guess. Well, it's not like all SQL Server's fault, but SQL Server made that guess because way up here, when we declared this variable, we took away SQL Server's ability to use the good part of the statistics histogram to make cardinality estimates. Instead, we use this awful goofy part down here, where if my mouse scroll wheel will cooperate for like 3 more seconds, just like live, please. If we look at the statistics for that really expensive index that we created, we'll look at the number of rows that we had, and we'll look at this density value. And this isn't going to give us the estimated number of rows, but it will give us how many rows SQL Server thought we were going to have to read. And that's about as close as a high school dropout can get to figuring out the problem. So like I said, this wasn't all the fault of the missing index request. We should do something smarter with that declare variable, do some doodads in there. But when you're adding indexes, especially when you're adding indexes that come from the missing index DMVs, you do need to spend some time thinking about them, thinking about the kinds of queries that might be asking for them. It's even better if you can look in the plan cache and correlate them to some queries that are asking for missing index. Have missing index requests on them, because a little workload knowledge can go a long way. It's a really important thing to understand where these requests are coming from, what queries they might help, and then testing like a wider range of queries to make sure that they don't have any terrible regressions as you add indexes. Were there any questions there? I saw something flashing, so I don't know.
And we do have something flashing. Let's see.
Yes, hopefully it's not just me.
Yeah, no, it's just it's the next speaker.
Oh,
Yeah,
right.
I think that was just Mohammed joining. I think that's what you saw for a second there.
Well, everyone must be saving their questions for him.
Blythe wants to know how to stop throwing out her back when she does her deadlifts.
Oh, don't lift with your back.
Yeah, there you go.
Yeah, pretty good, right? So a lot of people talk trash about table variables, and they are quite often inferior to temp tables. There are many times when I see people using table variables and they're just having disastrous effects on queries. I'm not going to talk about that today. I have talked about that in the past on my blog. If you go to any of these links, these demos will be up later. If you go to any of these links, you can read all about why I think table variables are bad in other places. But where they absolutely beat the stuffing out of temp tables is when we have to use them over and over again really, really fast. Now I have two identical store procedures here. One of them creates a temp table and then sticks some values into that temp table. We don't really do much else. This bottom query does the exact same thing, except with the table variable, right? Declare at T table, create # table. What I'm gonna do is run them in a loop, and hopefully execution plans are turned off, otherwise this will be disastrous. What I'm going to do is run them in a loop. So I want to see how long it takes each one of these to get to 50,000 executions. And I'm going to hit this, and we're going to let them run. And we're going to see what happens. And while this happens, someone tell me something interesting about themselves. Jeremy, you go first. I know all about Eugene. I've seen his wallpaper. It's terrifying.
Something interesting about me. Oh gosh.
You have about 10 seconds.
I have a bunch of really cool ghost stories, and anyone that wants to hear them can ask about them later to the GroupBy channel. I don't know.
Sounds
interesting.
good.
Lots of ghost stories.
I do like ghost stories, just not before bed. I get spooked when I wake up in the night to pee, and I'm like,
oh, why?
No, not that.
Stories. Exactly about bathroom trips. Every single one. That's where they'll come up.
Wow, man, I don't want to talk to you ever again.
I'm just kidding.
All right, so we see these two things finished. The first one that had to insert into a temp table 50,000 times took 20 seconds. The bottom one that had to insert into a table variable 50,000 times took 6.6 seconds. So table variables, despite all of their downsides, drawbacks, detractors, they do have a pretty good use when you have very, very high frequency execution, especially when you have queries where plan shape doesn't change performance. In other words, if you cannot care about performance too much, and if this plan shape doesn't affect performance, table variables can be a pretty good thing. For a lot more detail, there's a Stack Exchange Q&A that I took part in. There's a link for that there. Again, these things will all be up on the website later on when I stop being lazy. So we have about 7 minutes left. And with 7 minutes left, I'm going to choose which thing I want to talk about with my remaining time carefully, because I have a few windows left, but there's one thing that happened pretty recently that I thought was pretty interesting, and I think I would like to talk about that more than anything else. So there was a reason why this was called cigarettes when I first wrote it that I can't remember now. I don't smoke cigarettes. I quit smoking like 10 years ago, but man, every time I go to Europe, I'm like, get in my mouth. So what I have here is 3 indexes, and we'll talk about these indexes in a minute. But the important thing to note with these indexes is that they are pretty helpful to this part of my query. We have an index on, what do you call it there? The comments table that is very helpful to this part of the query. I'm going to show you the query plan real quick because I don't want you to think that anything terrible, awful is happening in it. They all get a pretty similar query plan. Actually, I'm going to show you all of these things by estimate first. Run these, buy us some more real estate. All 3 of these queries do roundabout the same thing. All right. When I run this top query, actually I'm going to run them all together because I don't want to run into Mohammed's presentation. I would hate to do that to him. So what I'm going to do is run all three of these together and then talk about them all together. I'm going to make fun of them all at once, like a team, the way they should be. None of them return any results. That's the beauty of all my queries. They don't return any results, so I don't have to worry about explaining if anything was wrong. So these all finish, and the execution plans are going to show us some oddball things. Now, the first query that I'm telling to use the primary key clustered index is the fastest one. The only other query that's also parallel is the second one, but this is nearly twice as slow, right? Yeah, 2.5. Oh, yeah, close enough. Again, high school dropout. You can take advantage of me in all sorts of mathematical ways. The bottom query is serial. This one doesn't use parallelism. If we go look at why the top query was faster, it's because of something kind of funny that happens with these sort operators. So this sort ran for 2.23, well, so in row mode plans, these times add up going from right to left. So this thing ran for just a little under 200 milliseconds once you shave off the 0.59 milliseconds. It spilled, and it spilled off about 30,000 pages, 28,000 pages there. And this second one did a little bit more work. You can see that when you add up the 740 there and the 1.13 there, this thing ran for a little while. And if you zoom in a little bit, we can see that this thing wrote 548,000 pages. The reason that that thing did what it did is easily explainable, but first I have to show you what's different in this query. You can already see that this sort ran for a little bit longer and this sort ran for much longer. And if we zoom in and look at why, well, this is about 52,000 pages, but this one is going to be about 927,000 pages. So this one spilled way more. The difference in why they spilled is in the threads. So if I hit F4 and we look at the actual number of rows, we can see that some skew starts up here immediately in the top plan, right? It's a little bit off, but it's not too far off. 95, 149, 210. Obviously, this thread's going to do the most work, this thread's going to do the least work, and these will sort of be in the middle. If we go look at this query, and we look at this index scan, things are way off here. We got a 91, a 371, a 90, and a 61. The reason why the spill on the bottom, or the spill in the second query is so much worse, is because when a parallel plan runs, each thread gets an equal amount of resources. It gets an equal amount of CPU. It gets an equal amount of memory. When unbalanced parallel threads spill, generally the threads that do the most work are going to spill the most. In the second query down, the fact that thread 2 had 371 rows on it here means that if we go over here and look, thread 2 has 520,000 rows on it. And the disparity between how much work each one of these threads is doing is a lot bigger. If we come up here and look, and we see what this did, these are all pretty close. So yeah, SQL Server didn't ask for enough memory, and yeah, SQL Server spilled some stuff out to disk, but at the end of the day, what made that second query worse was that SQL Server had sort of unbalanced rows on each thread. Now, there's a whole bunch of complicated stuff with this thing called the parallel page supplier that will tell us, that sort of assigns rows to parallel threads. And the reason that things got thrown off is because when I created my indexes up here, the one that SQL Server used in the second query, right, this one, it's a lot narrower. And so SQL Server had a harder time assigning pages in equal amounts because the parallel page supplier looked at key values and it got all freaked out. So there's a much, much longer explanation for that, but I'm coming up on my time here and I don't want to mess with Mohammed. So I'll just write a blog post about it and everyone can go read that later. So in order to not mess with Mohammed's time, because he has some very important things to say, I'm going to call this a day and blog about that for everyone's edification at a later date.